Hey there, we're still in Chapter 6 talking about quadrilaterals, and Lesson 6.3 is to test for parallelograms. So looking back at Lesson 6.2, we learned the characteristics of parallelograms. And this is if we know it's a parallelogram, then all these other things are happening. So if we know it's a parallelogram, we know that opposite sides of our parallelogram are parallel. That is by the definition. So we're going to mark our parallelogram up here. We also know that if it's a parallelogram, then our opposite sides will then be congruent. The third thing we know that is if it's a parallelogram, then opposite angles are congruent. So that angle is congruent to its opposite and to its opposite. So again, knowing that all of these things are happening because we know it's a parallelogram. So some other things we know, that consecutive angles are supplementary. Consecutive means ones that are back to back. So those two are going to be added together to equal 180. You could also say these two angles will also be supplementary, and so on around the parallelogram. Next, if one angle equals 90, then the other equals 90. That kind of fits into your theorem 6.5, because if this one's 90 degrees, then this one is also 90 degrees because it's supplementary, and so on. And then the last thing, the diagonals bisect each other. So if I have a diagonal from corner to corner and another diagonal, that does not mean that my diagonals are equal. It means that this side is now equal to this side. So if this side is 9, then that side is 9. But that doesn't mean that this side is 9 also. That just means that bisecting each other means that it'll cut the other one in half, but it doesn't mean that they're equal. So that's from 6.2. Now we're going to get into 6.3, and we're almost going to, not almost, we are going to use the converse of all of these things in 6.3. So if this happens, then we know it's a parallelogram. So we're trying to prove, without proofs really, that we have a parallelogram on our hands. So let's see some of the characteristics. The first one says, if both pairs of opposite sides of a quadrilateral are congruent, then I have a parallelogram. So if you see quadrilateral ABCD and you see you have two sets of congruent sides, you know that it's a parallelogram. So that's the converse of 6.3. The next one we could use is if both pairs of opposite angles are congruent. So if I have opposite angles that are congruent in a quadrilateral, then I can say that it's a parallelogram. Remember our parallelogram symbol that we can use rather than writing that long word. The next converse that we'll use is the diagonals bisect each other. So if I see a quadrilateral or a four-sided figure, and I see that I have diagonals that are not necessarily equal, but their parts are cut in half, then I can say it's a parallelogram again. And the last one is some new information. If one pair of opposite sides of a quadrilateral are both, and that's that big word that we need to, both of these things have to happen, both are parallel and congruent. So if I see quadrilateral ABCD and I have a side that are both congruent and I see they're parallel, I know that it's a parallelogram. So those are just some facts that we can show that we have a parallelogram and not necessarily a just a quadrilateral. All right, so let's keep on moving. Let's try some of this. So determine whether the quadrilateral is a parallelogram and justify our answer. So we know we have a four-sided figure, but what's going to tell us that it's a parallelogram? Do we have one of those 4 things up there that we showed? So the first thing is, do we have opposite angles that are congruent? Do the diagonals bisect each other? We're not really told any of that information, but we do know that 35 does equal 35, so I know that I have one pair of congruent sides, and I also know that 20 equals 20, so my other sides are congruent. So if I scroll back up, if both pairs of opposite sides are congruent, then I have a parallelogram. So because I have opposite sides that are congruent, then I know we have a parallelogram. To justify our answer, I'm just going to say theorem 6.9, which is right what we talked about right up here, theorem 6.9. All right, if you will stop this video and try your checkpoint on the next page. All right, and here is your answer. We have a parallelogram because we have one pair of sides that are both congruent and parallel. All right, a scissor lift, like a platform lift shown, are commonly applied to tools intended to lift heavy equipment. I think we have some of those in our gym sometime to hang those banners and stuff. We know that angle A is congruent to angle C. We also know that angle B is congruent to angle D. Explain why the consecutive angles will always be supplementary regardless of the height of the platform. So before we do that, we know that opposite angles are congruent. Which allows us to say that quadrilateral A, B, C, D is a parallelogram, right? Because of theorem 610. If it's a quadrilateral and opposite angles are congruent, then I know that it's a parallelogram. So why are the consecutive angles always supplementary regardless of the height? Well, we know that the interior angles, A and B, or B and C, D and C, or AD, we know that they're always going to be supplementary because it's a parallelogram. So no matter the height, you raise that lift, it's always going to stay 360, and then all of the angles consecutive angles will equal 180 degrees. I also know that because it's a quadrilateral, all my interior angles equal 360. If you remember that, n minus 2 times 180 from section 1. And that can never change. So that is a few reasons why, because it's a parallelogram, I can say that those angles will never change. So look, go ahead and stop your video and go ahead and do your next checkpoint. And there is your answer, answer B. All right, moving on. Use a parallelogram in algebra to find the values. So find the values of x and y so that our quadrilateral will be a parallelogram, and then justify your answer. So if I look at this quadrilateral, I know to be a parallelogram, I need my opposite sides to be congruent, and that it just depends on how you'll solve. Depends on what type of information you will be given. So I know that my opposite sides are AD has to equal BC. So I know that 3 times y plus 1 must equal 4y minus 2. And then on the other side, I have AB for x minus 1 must equal DC. 3 times x plus 2. So when I solve, of course, I need to distribute. 3y plus 3 equals 4y minus 2. I'm going to get my y's all on one side. 3, because that cancels, equals y minus 2. If I go ahead and add 2 to both sides, I'm running out of room. Y is going to equal 5. So I have y, and now I need x to make my opposite sides congruent. So I need to distribute over here also. 4x minus 1 equals 3x plus 2. Adding 1 to both sides, subtracting 3 from both sides. So I know that this cancels, and so does that. So I have x is going to equal, oh, guess what? I didn't distribute correctly, so I need to make sure that I do distribute correctly. So x is going to equal 7. All right, go ahead and stop your video and try your checkpoint. Here is your answer, knowing that one side must be congruent and parallel. All right, just a little refresher. To prove a quadrilateral is a parallelogram, if we look for one of these things, then we can prove parallel. So if they have one characteristic, say I know it's a parallelogram because I have parallel sides, well, then if it has one, it has all of them. So just keep that in mind. All right, last problem, our coordinate geometry. A quadrilateral, we have QRST with the vertices. Determine whether the quadrilateral is a parallelogram. Justify your answer by using the slope formula. So you'll be given different instructions on how to solve. So if opposite sides of a quadrilateral are parallel, then it's a parallelogram. We know that the sides are parallel by using the slope formula. Remember, because parallel lines have the same slope. Because of time, instead of doing 4 slope formulas, and I'll give you your slope formula, m equals y2 minus y1 over x2 minus x1. So if you were not given a graph, so say we don't have our graph, you would have to do 4 slope formulas. But because of the sake of time, we're just going to count. Remember, rise over run. So QT will go 1, 2, 3, 4 over 1. And then RT, or RS, 1, 2, 3, 4 over 1. So we're in good shape for right now. Let's try the other one. From S to T, so go up 2, to the left, 1, 2, 3, 4, negative 4, so we'd say negative 1/2, and then up 1, 2, it's going to be close, 1, 2, 3, 4, negative 4, so we have a negative 1/2 because our opposite sides have the same slope. Our opposite sides are parallel, which means because of our definition, we know that it's a parallelogram. All right, and last, real quick, I'm just going to show you the answer. If you were needing to do the distance formula because you weren't given a graph, the distance formula is going to show if your sides are congruent. And remember, the slope formula shows if they're parallel. So if you want to try that one on your own, because my distances, one is 20, one is 25, I know that it can't be a parallelogram because my opposite sides have to be congruent. And both slopes are not congruent, so I know that I cannot be parallel. So that's the end of 6.3.